Alright, welcome back to Mr. P-Ups with Algebra. This is Unit 3, Topic 1, Lesson number 9, and we're dealing with residuals here. So we're talking about distance away from the average. So each data point, now it's a little bit hard for me to see which ones are which. I'm just going to go with this. So I'm going to say n is 1, 2, 3, vertical distance from the y equals x. So this is y equals x, so that's up for every one. It goes up, it goes right one. And n is vertical distance, that means straight up and down, is 3 away. Now, I think this is B right here. It's hard for me to see. 1, 2, 3, so that would also be 3. D looks to be right on the line. I think this is E, 1, 2, 3 as well. I think this is I, so that would be 1 away. G is right on the line. L is 1 away, and X is 2 away. Now, check to make sure that I have the right letters. These are the right numbers. They just might not be in the right order, so no big deal. What is the sum of all these numbers? 3, 6, 9, 10, 11, 12, 13. So what is the average vertical distance of points of line X? So that's 1, 2, 3, 4, 5, 6, 7, 8. Whatever 13 divided by 8 is, and that's going to be 1 point something. Just going to guess about 1.8, give or take. You double check it. So in this lesson, Leo and Araceli are noticing differences in salaries, and they want to make some assumptions based upon what they see. Based upon the graph, estimate the correlation coefficient. Now, this is pretty weak. I'm going to say that a lot of these have pretty big residuals. So I'm going to assume that this is going to be about a 0.6. That's just my guess. I don't think it's very strong. It's pretty weak. It's kind of in the middle, maybe 0.5. Maybe I'm giving it too much. Estimate the average income for men in this time period. Now, this is pretty difficult. I'm going to use this line. This line is meant to be a trend line. It goes through the middle of the data. Estimate the average income. Now, I'm going to pick the middle of the line. Average income right here would be, give or take, about $34,000. And then for women, same place, $19,000. Leonardo Araceli calculated the linear regression for this data to be this. What does the slope of the line of regression mean about the average income? So it means the average income is increasing. It's going up $2.18 for every right one. Up to for every right one is what it means. So the men's income increased that much compared to women's for this much during the same timeline on average. Number 5, both Leo and Araceli were surprised at this graph. They calculated the regression line and got this. What does this equation say about the average income of men? Well, it tells you that basically over time that men with a bachelor's degree make less and less each year because the trend is going down. Leo wondered why the y-intercept would be this. Now, this is a great question because it looks like it starts at $70,000 back in the year 2000. But why would the y-intercept be 1.2 million? Because this is the year 2000, and since they didn't change the time in years to represent years since 2000, year zero is actually not the year 2000. The year zero is actually the year zero. So you'd have to go back 2,000 years. Now, if this trend continues and it goes back 2,000 years, yeah, it's going to have a really high height, which is going to be about $1.2 to $1.3 million, which does not make sense in the context of the question, because if you go back 2,000 years, 1.3 million is worth way more than it is now. So that would not make sense in the context of the question, which is the reason why anytime I'm dealing with time, I always change time from years into years since something else. So therefore, your y-intercept makes more sense, because this y-intercept doesn't make any sense in the context of the question. Now that you have already analyzed the results of the women, compare the results of the men and the women with at least a bachelor's degree. So what am I looking at here? Average income for women. So here's this woman. Notice that once again, the men's was decreasing, but the women's actually looks to be increasing over the exact same time period. So this is 2000 to 2011. Oh, I looked at it backwards. Okay, so it's actually this direction. But it only decreases by about 2,000, whereas that's a bigger difference than cutting by about, what is that, 8,000. So here to here is about an 8,000 difference, whereas here to here is only a 2,000 drop. So it didn't drop as much. So I guess that's closing the gap. Homework. Determine whether a linear or an exponential model would best fit. Okay, very easy homework. Now, just look at the data. You can tell that the data seems to be curving up. So this would definitely be a exponential function would be a better model, an exponential model, I should say. And this data looks to be like a straight line. So this would definitely be a straight, it would be a linear model that would best represent this data. And the reason why is because the data goes in a straight line. If I were to make a curve through this data, okay, that was a very poorly done curve. If I was to make a curve like such, you're going to have very big residuals. And you don't want big residuals. You want to use a line so that all the data is as close to the line as possible. Same thing goes for here. And I know this is a little bit harder to tell, but this residual is going to be pretty big compared to when you did the curve. There's almost no residual that was large at all. All right. Thanks again for watching. Please give it a like to help you learn something about linear versus exponential lines of best fit or curves of best fit and how they're useful with different sets of data. Please give it a like I just said, or subscribe if you haven't done so already. Thanks again for watching. Have a wonderful